Okay, so what I want to do today is review some trigonometry. So some people might hear that and then freak out. I don't want you to do that. This is it's a simple review. We're not going to be going into a lot of detail with trigonometry, but it is important for you to understand how to use some of these trig functions. So let's look at this triangle. So when we're looking at this triangle, we know that it is a right triangle because we have a right angle right here, which is an angle of 90 degrees. I know it's a right angle because it's got that little box right there. Now, I don't have this triangle labeled right here, so let's go ahead and do that really quick. Here's my labeled triangle, so you might want to go ahead and label your triangle on your notes if you're taking notes for the first time. And really, we have one side of this triangle, which is 4.7 meters, and we're looking for the two other sides and also this angle right here. So anytime that you see this weird symbol, this symbol right here, this means theta, and it's really just referring to some angle. So I'm given one angle right here. I need to get the other angle. And I need the two other sides. So a lot of times you'll also see that when we are looking at the vertical, we're going to call it y, and then when we're looking at the horizontal, we're going to call it x. So here's our triangle. I want to find these two sides. So in order to do that, I am going to use sol, ka, toa. Okay, so sol, ka, toa is referring to these three equations right here. And I say it funny like this because I'm emphasizing that A right there and the ka. So, sol is referring to sine of theta is equal to the opposite divided by the hypotenuse side. So sine is a trig function, and it is its own special function. So I'm not multiplying sine to this number of theta. I am taking this number and taking the sine of that. So it's its own special function. It has its own special button on a calculator, which is why you guys need to have a scientific calculator. But really in this class, you're just going to learn how to manipulate the equation like we've been doing, and then it's just a button on a calculator. That's really all it is. So sine of theta is equal to opposite. So the opposite side of the triangle divided by the hypotenuse side of the triangle. So we're going to talk about what these terms mean in just a second, but it's referring to a specific side of the triangle. Then you have ka, which is cosine of theta, and that's equal to the adjacent side of the triangle divided by the hypotenuse. So that is the ka and sol, ka, toa. And then toa is the tangent of theta, and that's equal to the opposite side divided by the adjacent side. So we have three sides of a triangle. We have the hypotenuse, the adjacent, and then the opposite side. So if you take sine of that angle, that should be equal to the opposite side divided by the hypotenuse. That's what it's saying. So it would be good for us to know exactly what that means, what the opposite side is, what the adjacent side is, and etc. So let's go ahead and look at that. So whenever we're looking at our triangles, the hypotenuse is the easiest one to identify. That is always opposite of the right angle. So the right angle is right here. So the hypotenuse will be the side that is not touching the right angle. So this is our hypotenuse right here. So if I had this triangle right here instead, here's our right angle, so this has to be our hypotenuse. It's going to be the side that is not touching the right angle. Opposite and adjacent refer to being opposite and adjacent of the angle that you're referring to. So it really depends on what angle you're looking at. So when I'm looking at this angle right here, the 33, Hypotenuse will always be the same, so this is always going to be the hypotenuse right here. That's always the hypotenuse because it's not touching the right angle. This side right here is touching this angle. So when I'm referring to the angle of 33 degrees, this side, it will be the adjacent side because it's touching that angle. When I'm looking at this side and looking at this angle, this is not touching the angle, so it will be the opposite side. So the opposite side is the side not touching the angle. The adjacent side is touching the angle. And it will change depending on your angle. So let's look at this angle now. So when I'm referring to this angle, this will still be the hypotenuse, but now this side is touching this angle. So then this side becomes the adjacent, and then this side is not touching this angle, so this side becomes the opposite side. So it really depends on whatever angle you're referring to. So if I have, let's see, this angle. So here's another triangle, and I'm looking at this particular angle of the triangle. Okay, well, first of all, let's identify the hypotenuse. That's the easiest part. So this is the right angle right here. So the hypotenuse will never be touching the angle, the right angle. So that's the hypotenuse. So when we're looking at this angle right here, this side is touching, so that is the adjacent side. This side is not touching, so this is the opposite side. So it will change based on the angle that you're looking at. Okay, so let's get back to our problem and solving our problem. Okay, so we're going to use theta 1, which is 33 degrees, and x is equal to 4.7 to solve for, let's say, the h side. Okay, so we're going to solve for h. We want to find h. We know that this side is 4.7. We have the angle, so we don't have two sides. So the only thing we can do is use so ka toa. So the first thing I'm going to do is decide what side is what. Is it opposite, adjacent, or hypotenuse? So we're looking at this angle right here. This is the angle that I know the value for. So we're going to look at that angle. So this side is always the hypotenuse because it's not touching the right triangle or the right angle. This side right here, the x, since it's touching this particular angle, it will be the adjacent side, and then y will be the opposite side. Okay, so now I've identified my sides. I know that I'm looking for h, and I have a right here. So since I have the adjacent, I'm looking for h. I would like to have an equation that has both the adjacent and the hypotenuse. So when I look at so, which is sine of theta, which is opposite over hypotenuse, I have theta, which is 33 degrees. I do not have opposite. Opposite is the y side. I don't have that, nor do I have the hypotenuse. So just like we've been doing, if we have an equation with more than one missing variable, we can't use it. So let's look at the next one, which is cosine is equal to the adjacent over the hypotenuse. So I have theta. I have the adjacent side because x is the adjacent side. And I'm looking for the hypotenuse. So I'm going to use cosine of theta. So I'm going to plug it into my equation. Cosine of theta. Theta is always going to be an angle, so please do not put the sides of the triangle in the cosine, sine, or tangent functions. It's always the angle, which is 33 in this case. And that's equal to the adjacent side. Okay, so adjacent is this. 4.7 divided by the hypotenuse. All right, so let's go ahead and plug in cosine of 33 and see what we get. So just cosine 33 on your calculator. Please, please, please go ahead and try this on your own. What you should get is 0.8386. If you do not get this number and you get some weird number like a negative number, that means that your calculator is in radian mode, not degree mode. All right, so now I have this number is equal to 4.7 divided by h. I can go ahead and solve for h, but it would be easier for me to solve for h if I do not have h on the bottom. So I want to put h somewhere else in the equation. So I'm going to multiply both sides by h. I'm not solving anything yet. All I'm doing is just manipulating the equation to make it look nicer. So what I have is 0.8386 times h, and that's equal to 4.7. This looks a lot easier to solve than this. So now I can clearly see that in order to solve for h and get h by itself, I'm going to divide both sides by 0.8386. Okay, so h is equal to this divided by this, so 4.7 divided by 0.8386 gives me 5.6. And since this is meters, the hypotenuse will also be in meters. All right, so now I have two sides of my triangle. So I can go ahead, use SOHCAHTOA to solve for y here if I really wanted to, but there's an easier way to solve for y. All right, so I want to solve for y here, but I have two sides of the triangle. So I could use, if I wanted to, I could go through and use SOHCAHTOA, and at this point I could probably use some sine, and then I could use TOA if I wanted to. But there's an easier way, and that is called the Pythagorean Theorem. We're going to use a squared plus b squared is equal to c squared. Because I've got two sides of the triangle, this is the easiest thing to do. So c will always be the hypotenuse side, and then a and b, it doesn't really matter what side you pick. It's just c is always the hypotenuse. So a squared, so we have 4.7 as one side, so we can use that. 4.7 squared plus b squared. So that'll end up being our y side right there, our unknown side. And c squared is equal to c squared, so that's the hypotenuse. So 5.6 squared. Okay, so 4.7 squared should give me 22.09 plus b squared is equal to 5.6 squared. So that gives me 31.36. All right, so I'm going to subtract 22 from both sides. Since I'm adding it here, I'm going to subtract it to get rid of it. So b squared is equal to this minus this. So that's equal to 9.27. I'm not done though because I have a squared here. So I'm going to take the square root of both sides. So b is equal to square root of 9.27. So we should get about 3.04 roughly. So y is equal to 3.04 meters. So if you have two sides of the triangle, you can use a squared plus b squared equals c squared. If you only have one side of the triangle, though, and an angle, you have to use SOHCAHTOA. You don't really have this option yet. So let's go ahead and solve for the last part of this problem. We have all three sides of the triangle now. Now we want to solve for this angle right here. And yes, if you remember, all of the angles in a triangle will equal 180. So if you add all the angles up and then subtract it from 180, you can go ahead and solve for this. But I'd like to show you how you would solve for the angle if you did not have two angles. So, but on a test or quiz or assignment, and you need to solve for an angle and you can use that method, please do so. Alright, so if I'm solving for this angle right here, and I'm going to pretend like I don't have this angle here, I'm going to use SOHCAHTOA. So again, what I'm going to do is I'm going to assign hypotenuse, opposite, and adjacent sides. So right here, this is always going to be the hypotenuse because it's away from the right angle. This side will become the adjacent because I'm looking at this angle right here. So that is the adjacent side to this angle. And then this side is the opposite side because it's not touching that angle right here. So I'm looking for this angle. I have all three sides. Since I have all three sides, I can pretty much use any of my equations here. So let's look at sine of theta is equal to opposite over hypotenuse. So let's see if we have enough to solve here. I do not have the angle here. So I do not have the angle here. That's unknown. But I have the opposite side, which is this side right here. That's the opposite side. And then I also have the hypotenuse side, which is right here. So I have enough information to solve. So sine of theta. Alright, so now I have sine of theta. Theta is unknown, so I leave it as the weird symbol. And that's equal to the opposite side, which is 4.7, divided by my hypotenuse of 5.7, or 5.6. So 4.7 divided by 5.6. That's equal to 0.839. So sine of theta is equal to that. So now I need to get rid of the sign, and a lot of students are prone to say, well, let's divide by sine. You're not multiplying sine here. Sine is its own special function, so you need to take the inverse of sine. So you have to take the opposite of sine. In this case is going to be the inverse, and it looks like this on your calculator. So sine to the negative first, that's called the arc sine. And if you do that, that will get rid of the sine. So let's do that on both sides. Alright, so it should be a number on or a button on your calculator, and usually what you're going to do is press second and then the sine button, and that should give you the inverse sine. So the opposite of sine is not cosine, it is sine to the negative 1. So when you do this in your calculator, you're going to get 57 degrees. Okay, so if we have cosine, the opposite of cosine would just be cosine to the negative 1. If I had tangent, the opposite of that would be tan to the negative 1. And all these buttons should be on your calculator. Alright, so let's look at another problem. So right here, we have a side that equals 500 meters. We're looking for this side right here. So we're going to call that y. And then theta right here is going to be 20 degrees. So I'm given just one side and an angle, and I'm asked to find another side, so I have to use SOHCAHTOA. So what I would do if I were you, I'd pause the video, try to do this on your own, and then go to see if you did it right. So pause, do it yourself, then check it. All right, so I hope you've tried to do this problem on your own. When we look at this, the first thing I would do is assign sides. So this is the angle I'm going to be looking at. I have the value of that angle. So this is my hypotenuse side. This side right here is my adjacent side. And then this side, because it's not touching this angle right here, is my opposite side. So this is the adjacent because it's touching this angle. So I'm looking for opposite. So I would like to find an equation that has opposite, but opposite is the only unknown variable. So let's look through our equations. So sine of theta is equal to opposite over hypotenuse. Well, I have theta, that's 20. I'm looking for opposite, okay, so that's unknown, and I do have the hypotenuse, it's 500, so I can use this equation. The only other equation that has the opposite in it would be this one. But if I look at this equation, I do have theta, and I'm looking for opposite, but I also do not have adjacent, so I cannot use this equation. So I'm going to use this one right here. So sine of theta is 20, is equal to the opposite, which is unknown, divided by the hypotenuse of 500. So sine of 20 gives me 0.342. That's equal to the opposite divided by 500. So in order to get opposite by itself, I'm going to multiply both sides by 500. So opposite is equal to 500 times this, which gives me 171 meters, roughly. So this should be our answer. This is our closest answer. All right, so this concludes our review of trigonometry. Please make sure you're doing the practice problems I'm assigning. And make sure that you're assigning the sides. So is it hypotenuse, opposite, or adjacent side? And then pick the equation that'll work best for you. So it should only have one unknown variable. And hopefully it's the variable you want to solve for. All right, I'll see you guys in class.